Hi, welcome to the new video. So let's continue from where we left off talking about force vibration. So in this case, we finally found out the expression for the response of the system like this. This seems to be a pretty long equation, so we need to simplify it. So some mathematical manipulations to simplify it. Let's assume there is let's substitute a is equal to, I missed out some, let's assume this is a. Then we can make the substitution like this. Why? Because if we take the square of this particular term, and if we take the square of this term and add both of these things together, then we will get 1. That means effectively it is satisfying the constraint that sine square plus cos square phi is equal to 1. So we can go ahead and do this approximation. Now, if we make this kind of substitution and plugging this back here, see, then 2 zeta r can be represented as root a so this can be cos phi times root a, then this can be also sine phi times root a. So effectively x of t can be written as x of t equal to our delta static divided by 1 by root a, because root a comes out of the whole expression. Then we will get a cos phi sine omega t plus sine phi cos omega t. So from high school trigonometry we know this is the expression for cos of omega t minus phi. So we plug that here, and then we can write this as x of t equal to delta static divided by root a cos of omega t minus phi. So that means we have a forcing function which is varying like this, cos f0 cos omega t. Now, so there is a definite phase difference between the excitation and your response, and it is given by phi. So that is the phase difference. Now let's talk about amplitude. Amplitude of the response is given by this particular term. Now if we expand this particular term here, this is completely known. This is a function of f0, your system stiffness, your system mass, all this, your damping coefficient of viscous damping in the system. So all this amplitude will depend upon all of these things. And if you want to calculate the phase difference, then the equation is given here. This is arrived from the approximation we made for sine phi and cos phi in the earlier slide. So now we know everything. We know the amplitude of the response in terms of our system parameters. We know how to calculate the phase difference also. Now what we will do is, this was slightly a lengthy process to arrive here. Now we will look at whether there is an easy way of reaching here, or as a comparatively easy way of arriving here. That we will do in the next video. So to sum up this video, the key results which have arrived can be put in a box. So let me do that finally. So all these are very important equations. So this is the response against an excitation of this, and this is the amplitude given by this expression, and the response is having a phase difference given by this value. Very important. So let's put this inside a box, because this is important. And always remember, there is a 1 minus r square, then we are squaring the whole term together. So always remind there is an r square here. Most of the time students make mistakes and they lose their valuable marks here. So always keep this in mind. Thanks for watching.